Hello everyone, once again welcome to new lectures that is called loss of charge method. It is in previous lectures we are talk about measurement of low resistance using ammeter voltmeter method, Kelvin double bridge method, and using your medium resistance measurement, which is one of the special measure bridge that is called Wheatstone bridge we will develop. In the Wheatstone bridge and your Kelvin double bridge, we necessarily manage to differentiate that. In Wheatstone bridge, we only measure the medium resistance between 1 ohm to 100 kilo ohm. We does not manage to measure the high resistance that is above the 100 kilo ohm as a limitation that it can cause the I square RT losses. And also Wheatstone bridge has a limitation that it cannot measure the low resistance due to this contact leads. That's how why we can measure the using the Kelvin double bridge method, where the lead contacts carry some error, and we will manage some of the P by capital P by small p, capital P by small q ratio that will causes our bridge to be balanced. In today's lecture, it is one of the important and I say one of the interesting method for measurement of high resistance, that is called loss of charge method. This basically what is mean by high resistance measurement. When I suggested to one of our student, what is mean by high resistance? The high resistance means if we suggesting about the resistance, it will opposing the flow of current. So what is mean by high resistance? One of the mean of high resistance should be it act as an open circuit. What is mean by open circuit? It means we do not want any current to flow through it. One condition to be that, and the voltage should be infinite across it. Voltage should be infinite. Or in case of high resistance acid, the voltage should be very high and should be some minimum current, very milliampere current or microampere current should be flow through it. It's called as your high resistance element, I say. What are this application? One of the application is necessarily from the start I will say it is a insulators. What is insulators? That will insulate the two phases across it. And one of the more application is when you manufacture one of the motors or any electrical part, you have to be instruct your person that your electrical part should not have some connectivity with your outer surface. Okay, if there is some connectivity, there should be some effect of there is some shock. There should be shock to the person that will use it. Okay, so proofing it by shock proofing it, we have to be analyzed that it should not have there is no connectivity between some electrical part of say stator winding or rotor winding with respect to his upper surface. How do you know that? Using one of the method that is called loss of charge method, or we can suggest it by using the Mager method. We connect one of the lead to the upper surface and one of the lead to the your stator method, and if we measure the resistance, if the resistance between them is very high, it is approximately 100 of mega ohm or very large method, so we say there should be minimum or should be no resistance, no connectivity between them. By this, one of the method we suggested for this measurement is loss of charge method. What is effect? It is basically based on the charging and discharging method of your capacitor. It will suggested that the time period or a capacitor charging and discharging can be suggested by one of the time constant tau, that is represented by RC. Okay, this tau RC, what we suggest, it is suggested that if the capacitor voltage across it, it will charge in the circuit, it will take some time. Okay, what should be time? In case of your unit step function, it will causes some around 4 tau function to charging it, and some of the time it should be taken to discharge it. So if this particular resistance should be very high, if this particular resistance is very high, then time taken to charging is very high, so the time taken should be very high. Okay, then the time taken to charge a capacitor should be very high in case of RC circuit. Okay, so in loss of charge method, just we have to be suggested that we have to be calculate either charging time or we calculate discharging time of a circuitry. If we calculate if the time of a charging should be very high, then we suggested that the total resistance, the overall resistance, what we wanted to measure the unknown resistance should be high. So how should we calculate? So by this formula, if tau is equal to RC, this our formula should be there. If we know the time taken to charging and we have a fixed capacitance, then depending upon the time taken, we can know the particular value of resistance. It is one of the perfect and one of the accurate method of measuring the high resistance in the circuit. So in this see the particular circuit, we have some insular resistance R to be measured and connected in parallel to the capacitor. Its capacitance charging or discharging is measured by one of the electrostatic voltmeter. Okay, so the capacitor is charged to some suitable voltage by mean of battery. It takes some time and we have to be noted and allow after switch or using the close switch. When we close the switch, the capacitor is charging to particular time, and it's full. When it's full charge, we open the particular switch. In this particular way, the capacitor discharge is particular voltage charge through the resistance, and we noted the particular period of time during of discharge. So what should be the basic fundamental or a your perspective formula for this? If we assume the total current that should be discharged, it should be negative in nature. It is equal to minus of dq by dt, where by for a capacitor q is equal to cv. So we put q equal to cv by dt, and formula should for discharging current should be minus c dvc by dt. So current I is equal to vc by r. Okay, one of the fundamental for a capacitor for a resistance, the formula should be voltage applied across is in case of discharging vc upon r. From first and second, first equation is for capacitor and second is equation is for resistance. How it should be calculated? If it is a fully charged, the total charge voltage across the capacitor should be v, and we have to find out what is the total. If it is in series, is capital I is in a series, C and R should be in circuit, then VC upon R is the current that is flowing the circuit. By equating first and second equation, where I is equal to VC by R, putting that we have dVC by dt equal to 1 by R upon CR, then taking the integration of both, where log of VC is equal to 1 minus of CR plus log of A, then arbitrary constant A, which is equal to when you putting the initial condition that t equal to when switch is just open, the voltage across capacitor is V, as it suddenly does not be changed. So capital R, we have to find out the resistance of the circuit can be found out by calculating the time t. We know the total voltage V, what we having applied, and VC voltage that should be charge at particular time during the discharge, maximum voltage that will be climbing upon. So by this particular time, we can know the particularly the resistance of a circuit. This accuracy of measurement is depending upon the method implementation to reduce the circuit. Let's start with, if vc is the total voltage, V is the total voltage, and the at particular time when we step down, the voltage across the capacitor should be V of C. Okay, the what we drop down V minus VC, we have to calculate whatever time taken, it should also be calculated. By this we calculate the total resistance in the circuit. The, as I say, the accuracy of voltmeter measure to be very accurate. It have a ratio of E by E. E is basically voltage applied, V is the total voltage across the system. So this method is very tedious and time first of all, as the discharging is resistance is very high, the timing for discharge is very high, so it is very time consuming and very tedious method. But as I say, it is one of the perfect method, but having some of the errors. What are the errors? First method is, every insulating body will have some leakage current, since we cannot get an ideal insulators. So this leakage current can be causes some inaccuracy in the system. Hence, in order if to reduce this leakage, insulation resistance of capacitor and voltmeter must be very high, one of the first method. So in this way, This insulation material will be absorption effect and some of the current due to this resistance and absorption causing some reading to be error. Now second thing, that is error due to the variation is insulation resistance due to variation in temperature. As I say, resistance of any material can be changed with temperature. If we measure the particular value of resistance in a temperature of 20 degrees Celsius and then measure at 40 degrees Celsius, due to the temperature there should be variation, and for this we have to be kept control the temperature variable quantity into the nature for while measuring to it. Now third quantity, that is called error due to time of application of voltage. So as I say, the effect of this absorption in association with almost all insulation material, that they will carrying some of the there is some leakage current in them. Due to this current, due to absorption effect, the time for which voltage is applied is different, so it does not be constant at all. This value of absorption current is different at different instant of time, so due to accuracy measurement will be lost. That's it. That is for loss of charge method, and what are this errors should be there. So due to this overall key, loss of charge method is very simple method, having some smaller thing, like we have only used capacitor and timer for measurement. But as I say, they carry some of the errors, so we have to be take down this method, so we does not allow in our lab and perspective, and we use some other method that is called Megger. ठीक है, मेगा ओम रेजिस्टेंस मैटर. Thank you all of you for this particular lecture. We will continue our next lecture for a Megger. Thank you so much.